The dinosaur dream, from imagination to genetic reality. Dinosaurs. These magnificent creatures, extinct for millions of years, continue to captivate our imagination. From childhood dreams of encountering a T-Rex to blockbuster films like Jurassic Park, dinosaurs hold a unique place in our collective psyche. But what if this fascination could transcend fantasy and enter the realm of reality? Could we, with our current scientific prowess, actually bring back these prehistoric behemoths? Scientists today are exploring innovative techniques to manipulate genetic material, opening up a Pandora's box of possibilities in the field of de-extinction. The quest to resurrect dinosaurs is not just about bringing back long-extinct creatures. It's about pushing the boundaries of science and exploring the potential of genetic technology to reshape our world. Can we really reverse evolution? The concept of bringing back extinct animals known as de-extinction might seem like something straight out of a science fiction novel, but it's a field that's gaining increasing traction in the scientific community. The central question is, can we really reverse millions of years of evolution and bring back creatures that have long vanished from our planet? The answer, as with most things in science, is complicated. One of the biggest hurdles in resurrecting dinosaurs is the challenge of obtaining their DNA. Unlike in the movie Jurassic Park, where dinosaur DNA is miraculously found preserved in ancient mosquitoes trapped in amber, the reality is far more complicated. DNA degrades over time, and even with the oldest recovered genetic material, reconstructing the complete genome of a dinosaur remains a monumental task. However, despite the challenges, scientists haven't given up on the dream of bringing back extinct creatures. By identifying and activating dormant genes, scientists believe it might be possible to bring back lost traits, essentially creating a hybrid animal that resembles its extinct ancestor. Decoding life, the power of ancient DNA. The quest to bring back dinosaurs hinges on our ability to understand and manipulate the very building blocks of life, DNA. Often described as the blueprint of life, DNA holds the genetic instructions for the development, function, growth, and reproduction of all living organisms. In recent years, the field of ancient DNA research has witnessed remarkable breakthroughs. Scientists have successfully extracted and sequenced DNA from a variety of extinct animals, including mammoths, woolly rhinoceroses, and even Neanderthals. These achievements have revolutionized our understanding of ancient life and provided invaluable insights into the evolutionary history of these species. Advanced sequencing technologies and computational algorithms are then used to analyze the data, comparing it to the genomes of living relatives to identify similarities and differences. The recipe for resurrection: challenges in dino DNA retrieval. While the successful extraction of DNA from mammoths and other extinct creatures offers a glimmer of hope, retrieving viable dinosaur DNA presents a unique set of challenges. The primary obstacle lies in the vast expanse of time that separates us from these prehistoric giants. Dinosaurs went extinct around 66 million years ago, an unimaginable timescale that makes the preservation of their DNA highly improbable. DNA, even under ideal conditions, degrades over time. The fossilization process itself, while preserving the shape of bones, often destroys the delicate organic material within, making it extremely unlikely to find intact dinosaur DNA within fossilized remains. Even if dinosaur blood were found preserved in amber, it's highly unlikely that it would contain sufficient quantities of intact DNA to reconstruct a complete genome. Section 5. Filling the gaps, genetic engineering to the rescue? The challenges of retrieving intact dinosaur DNA might seem insurmountable, but the field of genetic engineering offers a potential workaround. Instead of relying on finding a complete set of dinosaur genes, scientists are exploring the possibility of reverse engineering dinosaur traits in their living relatives, birds. Birds are the direct descendants of dinosaurs, carrying within their DNA remnants of their prehistoric ancestors' genetic code. By identifying and manipulating these ancient genes, scientists believe it might be possible to reawaken dormant dinosaur traits, effectively turning back the evolutionary clock. This process requires a deep understanding of avian genetics, sophisticated gene editing tools like CRISPR-Cas9, and a lot of trial and error. Section 6. Bringing back the mammoth de-extinction in the 21st century. While the prospect of resurrecting dinosaurs might still be a long way off, the field of de-extinction has already made significant strides with other extinct creatures. One of the most promising candidates for de-extinction is the woolly mammoth, a close relative of the Asian elephant that roamed the earth during the last ice age. The woolly mammoth, is an ideal candidate for de-extinction for several reasons. Its relatively recent extinction, around 4,000 years ago, means that we have access to well-preserved remains, including frozen carcasses, with intact DNA. Its close genetic relationship to the Asian elephant, which shares over 99% of its DNA, makes it feasible to use gene editing techniques to fill in the gaps in the mammoth genome. Several research groups around the world are actively working on bringing back the woolly mammoth using CRISPR technology to edit the genome of Asian elephant cells. Section 7. Rewilding the planet. The promise and peril of resurrecting ecosystems. The prospect of bringing back extinct creatures raises intriguing questions about their potential role in our modern world. Proponents of de-extinction, particularly in the context of rewilding, argue that resurrected species could help restore balance to damaged ecosystems and combat the ongoing biodiversity crisis. Rewilding aims to restore degraded ecosystems by reintroducing missing species, often large herbivores or predators, that played crucial roles in shaping their environment. For example, woolly mammoths, once they roamed the Arctic tundra, played a crucial role in maintaining the grasslands by suppressing tree growth and trampling the ground, creating ideal conditions for other plants and animals to thrive. Ethical dilemmas: playing God or righting past wrongs. The prospect of bringing back extinct creatures raises profound ethical questions about our relationship with nature and the responsibilities that come with wielding such powerful technologies. Critics of de-extinction argue that we're essentially playing God by manipulating life for our own purposes, potentially with unforeseen and potentially disastrous consequences. One of the main ethical concerns is whether we have the right to bring back creatures into a world that has drastically changed since their extinction. Habitats have been altered, climates have shifted, and the ecological interactions that shaped their existence might no longer exist. Introducing resurrected species into these unfamiliar environments could disrupt existing ecosystems, potentially leading to the decline or extinction of other species. Ensuring the well-being of resurrected animals, especially in the early stages of de-extinction efforts, would be paramount and require careful ethical consideration. The unforeseen consequences. Could resurrected dinosaurs wreak havoc? The idea of resurrected dinosaurs roaming the earth evokes both awe and trepidation. While the image of a majestic brachiosaurus grazing peacefully in a field might spark wonder, the possibility of a Tyrannosaurus rex terrorizing cities ignites primal fear. The potential consequences of bringing back dinosaurs, particularly large predators, are fraught with uncertainty and raise concerns about ecological disruption and human safety. Dinosaurs evolved and thrived in environments vastly different from our own. Their physiology, behaviors, and ecological interactions were shaped by millions of years of evolution in a world with different climates, vegetation, and prey species. Introducing them into our modern world could have unpredictable and potentially catastrophic consequences for existing ecosystems. Furthermore, the potential for disease transmission between resurrected dinosaurs and existing species is a significant concern. The future of de-extinction. A Jurassic Park or a new era of conservation. The dream of bringing back extinct creatures, whether it's dinosaurs, mammoths, or passenger pigeons, continues to fascinate and fuel scientific exploration. While the ethical dilemmas and potential risks posed by de-extinction cannot be ignored, the field also holds immense promise for conservation, scientific discovery, and our understanding of the interconnectedness of life. De-extinction technologies, particularly gene editing tools like CRISPR, have the potential to revolutionize conservation efforts. By introducing beneficial genetic diversity into endangered populations, scientists could help species adapt to climate change, resist diseases, and avoid extinction. These tools could also be used to create genetic backups of threatened species, preserving their genetic heritage for future generations. Ultimately, the future of de-extinction will depend on our ability to navigate the ethical complexities, mitigate the risks, and harness the potential benefits of these powerful technologies. Beyond the bones, the enduring allure of dinosaurs. Dinosaurs, even in their absence, continue to captivate our imagination. They represent a bygone era, a time when giants roamed the earth, sparking a sense of wonder and reminding us of the vastness of geologic time. The quest to bring back dinosaurs, while scientifically challenging and ethically complex, reflects our deep fascination with these creatures and our desire to connect with the distant past. Whether or not we ever succeed in resurrecting dinosaurs, the pursuit of this dream has already yielded invaluable scientific advancements. From revolutionizing our understanding of ancient DNA to developing groundbreaking gene editing technologies, the quest to bring back extinct creatures is pushing the boundaries of science and challenging us to rethink our relationship with the natural world. The allure of dinosaurs extends beyond the realm of science, inspiring artists, writers, filmmakers, and dreamers, reminding us of the power of imagination and the endless possibilities that lie at the intersection of science and fiction.